Hello students, this is Harish Konda. Welcome to my channel, The Chemistry Classroom. So today in MSET, we are starting the General Organic Chemistry, GOC. So what is GOC? How it is useful to your MSET? Today we are going to discuss. So before starting the class, I request you all, don't skip the video. You completely see the video. Up to the end you see the video. Why? Because it is very useful to you. So it is organic chemistry today we are going to discuss. So it is very useful for your entire chemistry. So don't skip the video. And one more, who are not subscribed, please subscribe my video and promote my video also and encourage my videos. So now we are discussing about the MSET, General Organic Chemistry. The major role is played by organic chemistry in MSET. So that we are going to discuss the fundamentals. In the organic chemistry, the fundamental topics we are going to discuss, that is called General Organic Chemistry. Not the topics, that hydrocarbons and heteroorganic compounds we are not discussing here. Just we are discussing about the fundamentals of organic chemistry. That is called General Organic Chemistry. So what is General Organic Chemistry? How we are discussing now? Let me see. So in General Organic Chemistry, so why that organic compounds? Why the organic compounds are introduced? Now we discuss. Generally, the natural occurring compounds, what are synthesized by the nature. What are synthesized by the nature, they are called organic compounds. Why? Because it is organ. Why? Because the nature is synthesizing. We are not able to synthesize artificially. That is, man cannot synthesize the compounds. In earlier state they thought the compounds are naturally occurred compounds only. Very first it is formic acid from formica. Formica means it is ant. From the ant, one compound we came to know, that is formic acid. It is in source so test. So it is called acid. Formica, from the formica it is secreted. So it is called formic acid. So like that compounds, they are synthesized from the nature only. From living organisms they are synthesized. So they are organic compounds. But later on the compounds can be synthesized in the laboratory also. So like that organic chemistry is developed. Friedrich Euler, the scientist name is Friedrich Euler, is synthesized a compound in the laboratory. So that's why the organic compounds can be synthesized in the laboratory also. It is a huge revolution in organic compounds. So what is the compound that Friedrich Euler synthesized? So he taken ammonium cyanide. The compound, it is ammonium cyanide. So what he did? So just he heated the compound. So when he heated the compound, in the ammonium cyanide is inorganic compound. In the compound, the atoms are rearranged. The atoms are rearranged to form one compound. Here you see the NH2CO NH2 compound is formed. Here you see two nitrogens. The two nitrogens are four hydrogens, and the four hydrogens, one carbon and one carbon, and one oxygen and one oxygen. So what happened here? Ammonium cyanide, the compound, when you heat it, the compound is rearranged to form one compound. This compound is very similar to the urea. What is the compound? It is urea compound. It is very similar. Very similar means it is the exact structure of urea compound. The urea is the organic compound. It is secreted. It is extract compound of the animals. The animals extract compound, it is urea, is very similar to this compound. So what it means, that ammonium cyanide, when it is heated, what you form? The urea you form. That means the organic compound is synthesized in the laboratory. So from there, that organic compounds are synthesized in the laboratory also, a huge wide area. So we are going to create. So the Friedrich Euler scientist, he created the urea. So like that the organic compounds are developed in the laboratory. So why that organic compounds we are discussing now we see. So in the organic compound it is called carbon compounds. What it is called? Carbon compounds. Why it is carbon compounds you see. So the carbon is the central atom in the compounds. The carbon is the central atom. All carbon compounds are not organic compounds. For example, the carbon dioxide, carbon monoxide and carbonic acid, like that we have. Even though they are not organic compounds, what we have? The carbon and the hydrogen, the two elements are must and should in the organic compound. So the organic compound is prepared by carbon and hydrogen. The two elements are the essential elements. What they are called? They are called essential elements in the organic compound. The two elements are going to form the compound, that is organic compounds, carbon compounds. Carbon is the central atom and it is bonding with hydrogen to form the organic compounds. So how it is formed, why it is formed, now one by one we discuss. The carbon is having some special characteristics. Due to that special characteristics, the carbon is forming so many compounds with the hydrogen. So what are the special characteristics? Now we discuss. The first characteristic. So the carbon is having tetravalency. What it is called? Tetravalency. Due to the tetravalency, the carbon is forming so many compounds. What is tetravalency? Here you see the carbon atomic number, it is 6. Electronic configuration 1s2, 2s2, 2p2. With this electronic configuration, here the 2s2, 2p2, it is the outer shell electronic configuration. In 2s orbital we have 2 electrons, in 2p orbital we have 2 electrons. With this electronic configuration, carbon can form only 2 bonds. But in all organic compounds, the carbon is forming 4 bonds. Why? Because to get stability, the carbon is bonding 4. When it is bonded 4, so automatically the carbon is getting octet. So with this electronic configuration, if it is undergoes the chemical bond, so what it form? The 2 bond pairs and 1 lone pair. Totally we have 3 pairs only you are forming. That means 6 electrons only you are formed. The 6 electrons is not getting octet, so the compound is not stable. To get the stability, what happened? The carbon, the 2s orbital electron is excited to 2p orbital. So 2s1, 2p3 electronic configuration. So how many unpaired electrons you are forming? 4 unpaired electrons you are forming. The 4 unpaired electrons are participating in covalent bonds. So the carbon is having tetravalency, tetracovalency. So here the covalent bonds are 4. The carbon is bonding 4. With excited state it is bonding. The 4 electron pairs are formed. That means 8 electrons are formed. The compound is automatically getting stable. So the carbon in excited state only is forming the organic compounds. So it is tetravalency. The carbon is having tetravalency. It is the first characteristic of carbon. And the second, it is catenation. So what is the property? It is catenation. Generally, very little amount of elements only they form the catenation property. So why? Because when the elements, the atoms are undergoing with the same atom, when the atom is bonded with the same atom, so what you form? One chain you form. So here the carbon, it can form with the carbon, so it can form with the bond with the carbon, it can form the bond with the carbon, like that the chain is increased. This property is called catenation property. Maximum the carbon and silicon, it is having the catenation property, in that the carbon is having high catenation property. The carbon can form with multiple carbon atoms to form a chain, that the property is called catenation property. It is the second special characteristic of carbon. The carbon can form catenation. The carbon can form the bonds with another carbon atom. So you can form the chain. So that is the special characteristics of carbon. That is the second characteristic. And the third characteristic, multiple bonds. Multiple bonds in between carbon. The multiple bonds can form in between the carbon atoms. The carbon and carbon can form single bond, and the carbon and carbon can form double bond, and the carbon and carbon can form triple bond also. So the multiple bonds are possible in the carbons. In between the carbons, you can form the single bond. In between the carbons, you can form the double bond. In between the carbons, you can form the triple bond also. It is called multiple bonds. Multiple bonds in between the carbon atoms you can form. That is the special characteristics of carbon. Carbon can form single bond with the compound. In the compound, carbon can form double bonds also. In the compound, the carbon can form triple bonds also. It is called multiple bonds between the carbon atoms. It is one more special characteristics of carbon. So here the carbon is having tetravalency and the carbon is having the catenation property. At the same time, the carbon can form multiple bonds between the carbon atoms. These are the special characteristics of carbon. Due to these special characteristics, the carbon is going to form a huge number of compounds. They are discussed in organic compound. With a combination of hydrogen, it is forming huge number of compounds. That all compounds are discussed in organic chemistry. So that is the special chemistry, that is organic chemistry. The carbon is bonding with the combination of hydrogen. It is going to form so many compounds that we are discussing in organic chemistry. How it is forming one by one we are discussing. Okay. So in organic compounds, how the carbon is going to form the bonds, now we discuss. So here in general, the carbon is undergoing hybridization. What are the hybridations are involved in organic compounds, now we discuss. Here you see the carbon is tetravalent. It is having 4 bonds. So how many bonds it is going to form? 4. If the 4 atoms are available to this carbon, that means the 4 hydrogens or the 4 carbons or 1 carbon and 3 hydrogens, like that, the atoms if they are available, that means the carbon is having 4 bonds, the 4 bonds with 4 different atoms. Such type of carbon is called saturated carbon. For example, if you don't available that atoms, for example, you see here the carbon and the hydrogen. Here the carbon is available with only 3 atoms. Here the same carbon also, it is available with only 3 atoms. It is not sufficient atoms to form 4 bonds. So what happened here? The carbon and carbon is forming one more bond. In that one is sigma bond and another one is pi bond. So that means the carbon is not available with 4 different atoms. So that carbon is it is not having the 4 atoms. So this type of carbons are called unsaturated carbons. Generally the carbon is having 2 type carbons. The one is called saturated and another one is called unsaturated. So when the saturated carbon you form, the carbon is having the sigma bonds. Here how many sigma bonds it is forming? 4 sigma bonds. To get 4 sigma bonds, how many hybrid orbitals are required? 4 hybrid orbitals are required. To get 4 hybrid orbitals, how many orbitals are participated? 4. In that one is s orbital, the remaining 3 is p orbitals. So what is the hybridization is involved here? sp3 hybridization. Why? Because the carbon has to form 4 bonds. The 4 bonds are sigma only. So the 4 sigma bonds if you want to form, we need 4 hybrid orbitals. Then in that one is s orbital, the remaining 3 is p orbitals. So the saturated carbon will undergo in sp3 hybridization. Here you see the 3 bonds are sigma, 1 bond is pi. Here the carbon is forming 4 bonds. But in that 4 bonds, 3 are sigma, 1 is pi. That means the 3 sigma bonds only form. The sigma bonds are formed by the hybrid orbitals. So how many hybrid orbitals are required here? 3 hybrid orbitals are required. To get 3 hybrid orbitals, how many orbitals are participated? 3. In that one is s orbital, the remaining 2 are p orbital. So what is the hybridization? Is sp2 hybridization. So one more example if you see here. In this compound, the carbon is forming 4 bonds. So here one is sigma, this one is sigma, these 2 are pi bonds. So the carbon is forming 4, but in that the 2 are the sigma and the 2 are the pi bonds. So the sigma bonds are forming only 2 for 2 sigma bonds. How many hybrid orbitals are required? 2 only. To get 2 hybrid orbitals, how many orbitals are involved? 2 only. In that one is s orbital, the other one is p orbital. So what is the hybridization? Is sp hybridization. Like that, in organic compounds, the carbon will undergo in three type of hybridations. One is sp hybridation, the second one is sp2 hybridation, and the third one is sp3 hybridization. If the carbon form 4 sigma bonds, that is sp3. If 3 sigma bonds, that is sp2. If 2 sigma bonds, that is sp. So like that, the carbon will undergo in hybridization. Now we discuss about the nomenclature, how the compounds are named or how the compounds are labeled. Why? Because in universally you have to get the same name. Why? Because wherever you go, so you have to get the same name only. Here for example, in India we call the methane, the CH4 compound is called methane. In other states also it is called CH4 methane only. Why? Because we have some unique rules to get the same name or same label for the compound. For that we have one international union, that is called International Union of Pure and Applied Chemistry. This union is called IUPAC, International Union of Pure and Applied Chemistry. With this IUPAC, we have some rules. Based on the rules, we are getting the nomenclature, we are getting the labels for the compounds. How we are labeling now, we see one by one. Here you see, for example, if you want to label a compound, compulsory you have to identify which compound is belongs to. What are the compounds we have belongs to? We have to discuss. Generally, the compounds are getting some groups. They are called groups, homologous series. What it is we see, for example, I am writing one saturated compounds. Here the carbon, only one carbon we have, the remaining are the hydrogens. What we are getting? CH4. The compound is CH4. Here one carbon, if it is saturated, so you have to form 4 bonds. The 4 with hydrogens only. What the compound you are formed? That CH4 compound you are formed. And again I am increasing one more carbon, then one carbon is increased. Here what happened? The 2 carbons are there. Here the carbon is forming 4 bonds, one bond with carbon it is formed, the remaining bonds with hydrogens. So this is the hydrogen, like that hydrogens. So similarly this carbon also forming 4 bonds, one with carbon and remaining 3 with hydrogens. So what the compound you are formed? The 2 carbons with 6 hydrogen, C2H6 compound is formed. So one more compound, I am exceeding one more carbon. Here the carbon has to form 3 bonds, this carbon has to form 2 bonds, this carbon has to form 3 bonds. So here what happened? That 3 carbons are bonding with how many hydrogens it is? 8 hydrogens. 3 plus 3, 6 plus 2, 8 hydrogens. So one more carbon I am increasing. So what happened here you see? This carbon has to form 3 bonds. This carbon has to form 2 bonds. This carbon has to form 2 bonds. And this carbon has to form 4 bonds. So 3 bonds. So what happened here? The 4 carbons. So with how many hydrogens it is bonding? With 10 hydrogens it is bonding. So like that the compounds we are discussing, all compounds are saturated carbons and they are having only carbon and hydrogen. They are called one group compound. They are called group compounds. They are called homologous series. Why? Because when you observe the 2 continuous compounds, the difference between 2 continuous compounds is same. Here you see C2H6 and CH4. The difference is CH2. What is the difference? It is CH2. Now you see C3H8 and C2H6. What is the difference? It is CH2. Similarly here also CH2. Like that the difference is same. In between the 2 continuous compounds, the difference is same, and in the mass, what is the difference? It is 14 units is the difference. This type of series they are called homologous series, and you are getting one general formula. In this compound, the carbons, if they have n carbons, so what is the ratio of hydrogen? It is 2n plus 2. Here you are getting one simple ratio, carbon and hydrogen ratio, Cn H2n plus 2. There the carbon and hydrogen ratio is n is to 2n plus 2. So one formula you are formed. This type of compounds, if they are saturated, if they satisfy this principle CnH2n plus 2, that compounds are called alkane compounds. What they are called? Alkane compounds. So in IUPAC, so we have to identify the compound which the compound is belongs to. So we have to identify the root word. What it is called? Root word. So the compound which is belongs to the group, so we have to identify, if you identify the group, automatically you can nomenclature the compounds. Now we identify how the compounds are identified, how the compounds are labeled, one by one we discuss. Now we see, for example, here I am writing one compound CH4. Here it is satisfying CnH2n plus 2. So this compound is belongs to alkane. So alkane is the root word for that compound. Very first, if you want to label the compound, compulsory you have to identify the root word which the compound is belongs to. So here the compound is belongs to alkane. Why? Because in this compound we have carbon and hydrogen only. The carbon is saturated carbon, so it is satisfying CnH2n plus 2 formula. So that's why the compounds are alkane compounds. In this alkane compound, it is a root word. In the root word, we have two words. So what we have? So we have it is the combination of two words. The one is called alk and the second is ane. So one is alk and the second is ane. So the alk is called prefix and the ane is called suffix. So the root word is a combination of two words. The one is prefix alk and the second is suffix ane. So here the alk indicates the number of carbons. So how many carbons are in that compound? That prefix indicates, the alk indicates number of carbons. For example, you see, if the alk equal to 1, that means in the compound only we have one carbon. If you have one carbon, the alk is replaced with one prefix. That prefix is called meth. What is the prefix? It is meth. For example, alk equal to 2. That means you have two carbons. So what it is replaced with? Eth you replace. For example, alk equal to 3. That prop you replace. Alk equal to 4. That is bute. Alk equal to 5. That is pent. Alk equal to 6. That is hep. If alk equal to 7, that is hex, hept, sorry, it is hex. And it is hept. Alk equal to 8, that is oct. Alk equal to 9, that is non. Alk equal to 10, that is dec. Like that the prefix you are substituted. There the alk indicates the number of carbons. In the number of carbons we are substituting. If in the compound we have only one carbon, that alk is substituted with meth. If you have two carbons, the alk is substituted with eth, prop, bute, pent, hex, octet, like that. So we are substituting. And the second word indicates the ane. The ane indicates the functional group. So what it is called? Functional group. So what is functional group? You see, generally in the compound chemical and physical properties are based on a bond or a atom or a group. The bond determines the chemical activities of that compound, or the atom is determines the chemical activities of that compound, or the group determines the chemical activities of that compound. That bond or that atom, that compound, that group is called functional group. What it is called? Functional group. For example, you see this compound, the CH4 compound it is. In CH4, the carbon is forming 4 bonds. The 4 bonds are sigma bonds only. If that CH4, this compound wants to get chemical reaction, what we have to, here the carbon is saturated, already it is formed the 4 bonds. So we are not able to form the 5th bond. So compulsory what you have to do? You have to break, you have to remove one hydrogen and there one atom is replaced. So what happened here? The hydrogen is removed and the X atom is replaced. So what it means? The hydrogen bond, the carbon and hydrogen, in between the carbon and hydrogen, we have one bond. The bond is involved in chemical reactions. Why? Because if you want to get react, compulsory you have to break the bond. That bond is influenced the chemical reactions of the compound. That's why the bond, the sigma bond, is called the functional group. So for example, one more compound you see. In this compound, the carbon is forming 3 sigma bonds and 1 pi bond. When you compare with the sigma bond, the pi bond is very weak. So automatically what will happen here? If you want to get reacted, the pi bond first it broken. So that means the pi bond is weak and the pi bond is involved in chemical reactions. That's why this pi bond is called functional group. For example, triple bond if you form, the 2 pi bonds you are formed, the 2 pi bonds are weak when you compare with the sigma bonds. So these 2 pi bonds are broken to get the chemical reactions. So the 2 pi bonds are the functional groups. Why? Because the entire chemical and physical properties are based on this sigma bond or this pi bond or this double bond. So what happened here? The bond is a functional group. So similarly, for example, you see the CH4 compound. So what I am doing? I am replacing one hydrogen with chlorine. So in CH4 and it is CH3Cl. The compound is CH3Cl. Here you see the difference here, the CH4 and CH3Cl. Here only one hydrogen is replaced with the chlorine. So what happened here you see, the 3 hydrogens are same only. Even though the 3 hydrogens are same, the compounds are not having same physical and chemical properties. Why? Because the only chlorine determines the chemical reactions of that compound. Why? Because in the place of hydrogen here we have the chlorine. So automatically that chemical and physical properties are changed. Because of this chlorine only, that physical chemical properties are changed. So this chlorine is called functional group. So for example, one more you see. So in this compound, the 3 hydrogens are same only. Here you have the hydrogen, the 4th one. Here you have the chlorine. Here you have one group, the OH group you have. So these 2 compounds are having 3 hydrogens are same. But even though the compounds are not having same physical properties. Why? Because of the OH, the compound physical activities are changed, the chemical activities are changed. So that's why the OH is called functional group. So the functional group will determine the chemical properties and physical properties of the compound. So based on the functional group only you are identifying the group, the root word. Here the alkane. The alkane indicates the root word. In the root word the alk indicates the prefix number of carbons and the ane indicates the suffix, that is functional group. Here if you have only one sigma bond is the sigma bond only the functional group. That functional group is called ane functional group. If you have the double bond is the functional group, that functional group is called ene functional group. If you have the triple bond is the functional group, that functional group is called ine functional group. So by that you are getting some root words, that is alkane and alkene and alkyne. So very first we have to identify the root word, then only you can nomenclate the compound. So here we are identifying, how we are identifying, now we see how we are going to nomenclate the compound, now we observe. So for example, for this compound I am nomenclating. In this compound you see the carbon and hydrogen only you have, that means the root word is alkane. Here how many alkanes, all carbons you have, alk equal to 1. That means what you have to substitute? With meth you have to substitute. At the place of alk you are substituting the meth. So the meth plus the function group is ane. So automatically what the name you are getting? The methane. The compound is methane. For example, you see in this compound, here the 2 carbons are saturated only and the carbon and hydrogen only you have. That is C2H6 is the compound. So in this compound, the carbon and hydrogens are there and all carbons are saturated only. So for this compound, what is the root word? It is alkane is the root word. Here alk equal to how many carbons you are identifying? That is 2 carbons. So it is called eth. So at the place of alk you are substituting the eth, the remaining it is ane. So the compound is called ethane compound. Similarly, one more I am writing. Here in this compound also the carbons and hydrogens only present. All the carbons are saturated only. So here the root word is alkane. What is the root word? It is alkane is the root word. Here alk equal to how many carbons you are identifying? That is 3. So the 3 means it is pro. So pro plus ane. So the compound is propane. What is the compound? It is propane. Like that you are nomenclating. One more example we'll see. So I am taking one more example. For example, I have 4 carbons The 4 with hydrogens it is bonded. The 4 carbons are saturated carbons, and carbon and hydrogen we have. So the root word is alkane again. So here alk equal to how many carbons we have? 4. So the 4 is called bute. So the bute you are replaced. So bute plus ane. So the compound what you are forming? The butane. What is the compound? It is butane. So one more compound I am writing, you see here. So in this compound also we have 4 carbons. The 4 are the saturated carbons only, and carbon and hydrogen only have. So the root word again it is alkane only. So in the alkane, alk equal to how many carbons you are identified? The 4. So what the name you are going to get? The butane name. The same name you are getting. But here you observe these 2 compounds are different. Why? Because in the first compound the carbons are in the chain, straight chain only. But in the compound, so you don't have the straight chain. Here you can observe the branches. It is called branched alkane. So in this compound you have the branches. So the branched alkane you are identifying. So for these branched alkanes, how we are going to nomenclate? We need some rules. The IUPAC rules we need. So here it is the alkane. We don't have the branches. So it is called normal alkane. This alkane is called normal alkane. So what you are identifying? That is N-butane are identifying. But in this compound we have one branch. What is the branch here you observe? The carbon branch you are observed. So to get the nomenclature, very first what you have to do? You have to nomenclate for the branch. So then only you can nomenclate the compound. So then the branch you are identifying, the branch with only 1 carbon the branch is formed. When the 1 carbon is formed, generally in the alkane compounds, if you have 1 carbon, so how many hydrogen should be? The 4 hydrogen should be. So the name of the compound is methane. What is the name? It is methane. To get the branch, what happened here? You see, the hydrogen is eliminated and it is attached to the carbon. So to get the branch, so what happened here? One hydrogen I am eliminating and I am adding to the chain. I am adding to the chain. So then only it is converted into the branch. So what happened? When you want to convert the alkane to the branch, so what happened? One hydrogen is eliminated. Then only it is converted as a branch. So what happened here? From the alkane, what you are doing? You are eliminating 1 hydrogen. To convert the branch, you are eliminating 1 hydrogen. So this group is called alkyl group. What it is called? Alkyl group. So there again you know the alk means it is number of carbons. If you have 1 carbon it is meth. If you have 2 carbons, eth, prop, like that. So here you have the branch. The branch is having only 1 carbon. So the alk equal to 1. So this branch is called methyl. What is the branch? It is methyl. If you have 2 carbons and the hydrogen is eliminated and it is converted as a branch, from the alkane, you are eliminated 1 hydrogen. So this group is called alkyl. In the alkyl, you have 2 carbons. So it is called eth. So it is ethyl. The group is called ethyl. Propyl, butyl, pentyl. Like that you are forming. So with that branch, so how we are nomenclating? Now we see. So now I am nomenclating for this compound. Here I am identified 1 branch. The branch is 1 carbon branch. That branch is called methyl. So in this compound, in this chain, the branch is added. So what is this compound? Here you see, you can observe in the chain, you have the 3 carbons. So when it is 3 carbons, what is the alkane? It is propane. But in the propane, it is not normal propane. Why? Because here we have 1 branch. What is that branch? It is methyl branch. So this is called methyl propane. The compound is called methyl propane. So here I am writing 1 more compound, you see. So here easily you can identify with the 1 carbon branch. That branch is called methyl. So here in the chain the branch is added. In the chain how many carbons you have? 1, 2, 3, 4, 5, 6. So 6 carbon chain is called hexane. In the hexane, so what happened? 1 branch you form, the branch is methyl. So its compound is called methyl hexane. What is the compound? It is methyl hexane. So 1 more compound I am writing. So here the branch, you can easily identify the branch. So what is the branch? That is methyl. So in the compound, how many carbons you have? Same 6 carbons. So it is hexane only. In the hexane you have the methyl. When you clearly observe, these two compounds are not same. Why? Because in this compound, the second carbon is having the branch. In this compound, the third carbon is having the branch. So the position of the branch is different. The two compounds are having the difference in the position of the branch. Here in the second carbon, the methyl group is there. In the third carbon, the methyl group is there. So it is called 2-methyl-hexane. This is called 3-methyl-hexane. So one more thing here you have to observe. So from here if you count the first carbon, second carbon, third, fourth, fifth and sixth. So generally, for example, from that side if you count, here it is the first carbon, it is the second carbon, third carbon, fourth and fifth and sixth. We are getting two different numbers. So from this side if you count, we are getting the second number. From that side if you count, we are getting the fifth number. What you have to use? Which is getting lowest number that you have to use. From here if you count, you are getting only two number. So that is 2-methyl-hexane. Like that you are nomenclating. So if you have same identical branches, so we have to use pre-prefix. What it is called? Pre-prefix you have to use. For example, I am writing one compound. So in the nomenclature, if you want to nomenclate the compound, very first you have to identify the parent chain. The parent chain indicates the compound. The remaining parts in the compound is called side chains, branches. So for example, here we have one compound. In this compound we have to nomenclate. How we are nomenclating, you see. First we have to identify the parent chain. So here so many possibilities are there. That possibilities first we count. So for example, here you see, so it is the first possibility. There the carbon is linked with this carbon is linked with this carbon is linked, like that we have one chain which is not discontinued. It is continuous chain we have. That is the first possibility in this compound. And the second possibility here you see, from here to here you have the second possibility. The second possibility I did it. And same similarly here we have the third possibility. Like that we have three possibilities in the compound. In the compound we have three possibilities. The first possibility, at the same time second possibility and third possibility. In the first possibility if you count 1, 2, 3, 4, 5, 6. So we have 6 carbons only. In the side chain, in the chain we have 6 carbons. So that related to hexane compound. In the second chain if you see 1, 2, 3, 4, 5, 6, 7. In the second chain you have 7 carbons. In the third chain 1, 2, 3, 4, 5, 6. In the third chain also you have 6 carbons. So in the first chain and the third chain you have 6 carbons. In the second chain you have 7 carbons. So which is having highest number of carbons? That chain is called parent chain. So the second carbon, that second chain is parent chain. So the parent chain is having 7 carbons. So this compound belongs to heptane compound. In the nomenclature, we are identifying the parent chain which is having highest number of carbons. That chain is called parent chain. So here in the second chain you have the 7 carbons. So the chain is heptane chain. So when the second chain is heptane, so what is this one? This is the branch. Why? Because in the parent chain you have one branch. That branch belongs to 2 carbons. That 2 carbons means it is ethyl. The group is ethyl. So it is ethyl heptane. The compound is ethyl heptane. So then we have to number the compound. We have to number the branch. So here you see the first carbon and the second carbon and the third carbon, fourth and fifth and sixth and seventh. Same similarly from here you count. So it is the first carbon, it is the second carbon, it is the third carbon, fourth and fifth and sixth and seventh. So where you count, so you are getting the 4 number. The same number you are getting on the 4th carbon only you have the side chain. If you have different number of carbons, if you face the different number of carbons, for from here if you count the 3 number, from here if you count the 4 number, what you have to prefer? The less number of carbon. The carbon which is getting less number, from there only how to count. So here from two sides you are getting the same number, so wherever you count the number is same. So the fourth position you have the ethyl. So what it is called? 4-ethyl. The compound is 4-ethyl heptane. Like that the parent chain you have to identify. The parent chain which is having highest number of carbons in the chain is called parent chain. Here the second chain is the parent chain. In that we have 7 carbons. So the compound is heptane compound. On that heptane you have one branch. That branch belongs to ethyl. So it is ethyl. At the fourth position you have the ethyl. So it is 4-ethyl heptane. That is the nomenclature. For example, you see this compound. So very first you have to identify the parent chain. So here you see this is the possibility. In the possibility you have 3 carbons. So the compound belongs to pentane compound. The compound belongs to propane. The compound belongs to propane. So when you have the chain, parent chain, these two are not in the parent chain. What it means? They are the branches. Which is not in the parent chain, they are the branches. Here you have the 2 branches. This branch belongs to 1 carbon. This branch also belongs to 1 carbon. Here we have two side chains you have. 2 side chains. The side chain is methyl. This side chain also methyl. When it is methyl and methyl, the both side chains are same. So what you have to do for prefix, you have to add one more prefix. Pre-prefix. It is called pre-prefix. So here, how many methyl groups you have? 2 methyl groups we have. So that's why you are adding pre-prefix, that is di you are adding. Di means you have 2. If you have 3, you have to add 3, tri, tetra, penta, like that only you are adding. So here you have 2 methyl groups. So what I am adding? Dimethyl. The compound is called dimethyl propane. In the dimethyl, where the methyl groups are there, it is the first carbon, it is the second carbon, it is the third carbon. In the second position only you have the methyl. So 2, 2 dimethyl propane. Like that you are nomenclating. Then the parent chain you have to identify. In the parent chain which is not the carbons, they are the side chains. The side chains that 2 are methyl. 2 or more side chains if you have, so you have to mention. If they are same, if they are identical, what you have to do? You have to use pre-prefix, that is di, tri, tetra, penta, like that prefixes you are using. So for example, one more type of compounds we discuss. So for example, I have one compound. So in this compound we have 2 side chains. Clearly we are observing it is 1 side chain and this is 1 side chain. This side chain belongs to methyl. This side chain belongs to ethyl. It is the parent chain. In the parent chain we have how many carbons? You have 6 carbons. So the compound is hexane compound. So you have the remaining are the side chains. Here in the second carbon you have methyl. In the third carbon you have ethyl. So here you observe the first carbon, second carbon and third carbon, fourth and fifth and sixth. So one side I am numbering. So what you are getting in the second carbon, third carbon, you are getting the side chains. For example, from here if we count 1, 2, 3, 4, 5 and 6. So what happened here? 2, 3. So very first you have 2, 3, that 2 plus 3, what you are getting the 5, or fourth carbon, fifth carbon you are getting the 4 plus 5, you are getting 9. So from here if you count, the second carbon is having one methyl group and the third carbon is having ethyl group. The sum of these 2 carbon numbers is equal to 5. Here the sum of 2 carbon numbers 4 plus 5 is equal to 9. So which is smaller? Here the 5 is smaller. That means from here only you have to count. It is the second carbon and the third carbon. So in these 2 carbons you have the side chains. One is methyl and the second is ethyl. So second position you have the methyl. So it is 2 methyl. And the third position you have the ethyl. So it is 3 ethyl. The one is 2 methyl and 3 ethyl. So which is written first? Which is alphabetically comes first, that is written first, so it is 3-ethyl. What is the compound? It is 3-ethyl. Why? Because E is the first, then comma 2-methyl. So why? Because the methyl, after ethyl only you are getting the M, E after M only. So E-ethyl, 3-ethyl, 2-methyl, compound is hexane compound. If you have different side chains, the different side chains if you are writing, so they have to mention the numbers also. Alphabetical orderly you have to write. So 3-ethyl, 2-methyl, hexane. Like that we are nomenclating for alkanes. So another compounds we see. So for example, I have this compound. In this compound clearly what we observe, one pi bond is there. The compound is having one pi bond. When it is having pi bond, the pi bond determines the chemical reactions. So the functional group is ene functional group. So the root word is alkene. What is the root word? It is alkene. Compulsory, if you want to form the alkene, minimum 2 carbons are required. Why? Because with one carbon you are not able to form the double bond. Why? Because if you have one carbon, the remaining atoms are hydrogens only. The hydrogens are not participating in double bond. So minimum 2 carbons are required to form the double bond. So in the alkene, the first compound I am writing with 2 carbons. The 2 carbons are involved in double bond. So the root word is alkene. So again here you see, in the alkene root word, you have the 2 words. The one is called alk and the second is called ene. So already we know the alk indicates the number of carbons, the ene indicates the functional group. So here alk equal to 1, 2, 3 like that, the prefix you are adding, then the ene is the functional group. So here alk equal to how many carbons you have? Alk equal to 2 carbons you have. That means the the eth is a prefix. So here what happened? The eth plus ene, the compound eth plus ene. So what you are getting? Ethene. The compound is ethene. One more compound I am writing, you see. So I am increasing 1 carbon in this compound. So what happened, you see? The pi bond is the functional group. So here also the root word is alkene. So here alk equal to how many carbons you have? 3 carbons. So alk equal to 3 carbons means it is pro. So what you have to write? The prefix pro. So pro plus ene. So the compound is propene compound. What is the compound? It is propene compound. One more example I am writing. So here the compound I am writing with 4 carbons. So alk equal to 4. So the 4 means it is but. The ene is there. So the compound is called butene. What is the compound? It is butene compound. One more I am writing here, you see. So here also 4 carbons you have. Here the double bond is the functional group. So 4 carbons double bond means the compound is butene. This compound also butene. But here what you observe, these 2 compounds are different. Why? Because the position of the double bond is different. Here the first and second carbon is involved in the double bond and the second and third carbon is involved in the double bond. Here the double bond position is different, so you have to mention the position of the double bond. Here the first carbon and second carbon is involved in the double bond. What it means? If the first carbon is involved in the double bond, that means with the second carbon only. If the second carbon is involved in the double bond, that means with third carbon only. If the third carbon is involved in the double bond, that means with fourth carbon only. If 10th carbon is involved in double bond, that is with 11th carbon only. So like that we mention. So first and second is in the double bond. Second and third is in the double bond. So we need not to mention the 2 numbers. Why? Because if the first carbon involved in double bond, what it means? With second carbon only it is formed. The second carbon involved in the double bond, what it means? With the third carbon only it is formed. So that means it is 1-butene. What they are mentioning? 1-butene. That means the double bond, the ene, it first and second carbon. Here you see the 2-butene. What it indicates? The double bond between 2 and 3 carbon. So you can write like this or you can write one more like. So it is but. That means 4 carbons you have. the ene at the first position, so one ene, but one ene we can write. Same similarly, it is also but, so the second carbon involved in double bond, so two ene, like that you can write. So here the double bond position how to mention the double bond. If it is first carbon and second carbon, we have to mention only first carbon. Second and third, we have to mention the second carbon. Third and fourth, we have to mention the third carbon. Like that only are nomenclating. So you see, you can write that two types. One is one butene and but-1-ene. Both are same only. You can mention the double bond position at first swap or in between the function group and number of carbons also. You can write that two types. So similarly, if you have the side chains in the compound, so like this, the side chains also you have to mention. So the first carbon is involved in double bond and it is the second carbon and third carbon and fourth carbon. The third carbon is having the side chain. The side chain is belongs to methyl. So the third position is having the methyl. It is 3-methyl. And the 4 carbons you have the compound is but. So there the first and second carbon is involved in double bond. So it is but-1. So here what is the double bond? You have the functional group. So it is ene is the functional group name. So what you say? 3-methyl but-1-ene. The compound name is 3-methyl but-1-ene. If you have the side chains, if you have the same type of side chains, if you have, so here you see the two side chains are same. The two are belongs to methyl only. The two we have to mention pre-prefix. That means di you have to use. So what I am using? Di. So it is dimethyl. Where they are located? At the third position only. So 3-3. The first 3 carbon is having 1-methyl. And the 3 carbon is having the second methyl. So what I am doing? 3-3. That means the 2 we have to mention 3-methyl and 3-methyl. So what I am doing? 3-methyl, 3-methyl. So 3-3 dimethyl but-1-ene I am writing. So like that if we have different side chains, if you have like this compound you have. So here one is methyl group and for example one is ethyl group. So what you have to write? The functional group is a double bond. The compound is alkene compound. 1, 2, 3, 4, 5 and 6. So it is hexene compound. In the first carbon only it is in the double bond. So hex-1-ene is the parent compound. Parent chain it is. So we have the two side chains. In that alphabetically the ethyl is first after the methyl. In the third carbon you have the ethyl group. In the fourth carbon you have the methyl group. So that it means the third 3-ethyl and at fourth position you have the methyl. 3-methyl hex-1-ene. Like that you are nomenclating. Similar nomenclature for alkynes also. If you have triple bond in this compound, so what happened? The root word is changed. It is the root word is alkyne. So the alk indicates the number of carbons. The ene indicates the function group. If you have triple bond in the compound, the function group is ine. So what you have to use? So it is the ine. So alk equal to 2 carbons. So eth plus ine. So the compound is ethine. Similarly you are writing here also if you have triple bond. So what is the compound? Alkyne. So in 3 carbons you have alk equal to prop. So prop plus ine. What you are getting? Propyne. Similarly here also if you are getting 3 bonds. So first carbon is involved with second carbon only. So need not to mention the 2 numbers. So 1 butane. Why? Because the function group is ine. So 1 butane or but-1-ine. The same nomenclature I am using. The same rules only I am using. Similarly here the second and third carbon is involved in triple bond. So it is 2-butane or but-2-ine. Like that you are mentioning the nomenclature. If you have the side chains, so if you have one side chain only, it is 3-methyl butane. So similarly if you have 2, so it is 3-3 dimethyl butane, 1-butane. So it's the same nomenclature you are using for alkyne compounds also. So we are getting the heteroorganic compounds also. So we have to get the root word first. If the root word if we find, we can write the nomenclature of the compounds. So we have to identify the root word. For that I am giving the root words for heteroorganic compounds. what is heteroorganic compounds you know? So what is hetero? If you have other than carbon and hydrogen, the other atom is called heteroatom. If you have other than carbon and hydrogen, that atom is heteroatom and the compounds are heteroorganic compounds. So what are they? You see here, for example, the first I am taking the halogen is the heteroatom. What is the halogen? It is X. X means, so X equal to maybe it is fluorine, or maybe it is chlorine, or maybe it is bromine, or maybe it is iodine. So the X is the heteroatom. So the carbon and hydrogen and halogen you have, the heteroatom you have. So the compounds are heteroorganic compounds. So heteroorganic compound, when you find the heteroatom, the entire chemical and physical properties are depends on this atom only. This atom is called functional group. So what is the functional group? It is halogen is the functional group. If the halogen is the functional group, the compounds are called alkyl halides. What it is called? Alkyl halide compounds. So when it is alkyl halides, so you have to get the root word. What is the root word? It is haloalkane. What is the root word? It is haloalkane. Halo means it is halogen. So if we don't have the halogen here, what is the compound? It is alkane compound only. So you are eliminating one hydrogen and you are substituted the halogen. So you are getting the alkyl halides. That means they are the compounds, they are the derivatives of alkanes. Why? Because if we don't have it is alkane, so one hydrogen is replaced with X, so it becomes alkyl halides. So what it means? They are the derivatives of alkane compounds. So you have one halogen atom. Here we have one halogen atom. That halogen atom is mentioned as halo. So the alkanes are indicating with halogen. So it is haloalkane. The compound is haloalkane. If you have fluorine, fluoroalkane. If you have chlorine, chloroalkane. If you have bromine, bromoalkane. If you have iodine, iodoalkane, like that. The halogen position also you have to mention. On the first carbon, if you have the halogen, one haloalkane. If you have the second carbon, 2 haloalkane, 3 haloalkane, like that the number you have to mention, which is comes the lowest number that you have to given. So that is alkyl halides. Haloalkane is the root word for the first compounds. And the second compound you see, the carbon and hydrogen and oxygen. The oxygen is the heteroatom. So here generally the oxygen can form 2 bonds. How many bonds the oxygen is formed? 2 bonds oxygen is formed. So what happened? Here one bond I am forming with hydrogen and another bond with carbon. So when one bond is formed with hydrogen, what happened? You are not able to continue this side. It is dead end. That means the hydrogen, because of the hydrogen, you are not able to continue this side. But here what happened here? The carbon, it can form 4 bonds. So the 3 bonds are empty only. We can form another carbon, like that the chain is increased. The chain is increased in the side. So this chain is called resin. It's called R. So the R, and one side what you have? The OH group you have. Why? Because this side it is the dead end. So here the hydrogen you have. So that means dead end group you form. That group is OH. So what you have formed? ROH. If here the OH group is the functional group. Why? Because in the carbon chain, here if you have the hydrogen, the compounds are alkanes. But here what happened? The hydrogen is substituted with OH group. So they compounds also the derivatives of alkanes only. So here the compounds generally they are called alcohol compounds. What they are called? Alcohol compounds. So if you have OH functional group, that functional group, because of that functional group, the compounds are called alcohol compounds. The alcohol compounds also the derivatives of alkanes only. Why? Because in the alcohol OH group, how it is formed? The hydrogen is replaced with OH group. That's why they are called the derivatives of alkanes only. So the derivatives of alkanes, so for the root word what I am doing, in the alkane, so I am eliminating the E. So I eliminated E, and here the last OL I am adding to the root word. So what happened? It is alkanol. What the root word here form? Alkanol root word you form. So for the alcohols, So I am getting one root word. The root word is alkanol. Why? Because they are alcohols. The lastly have OL. In the alkane, they are the derivatives of alkanes. So the E is eliminated. There the OL is added. So what you are getting the root word is alkanol. So for example, here you see the oxygen, it can form two bonds. So what happened? This side I am adding the carbon. This side also I am adding the carbon. So what happened here? It said this side you can increase the carbons. This side also you can increase the carbons. So here you are getting one resin. Same here also you are getting one resin. To get different shade, so one is called R1, the second is called R2. The two R1 and R2 is linked with O. The two R1 and R2 linked with O. So here what happened here, you see the oxygen, this side alkane chain is there, this side also alkane chain is there. The two alkane chains are linked with oxygen. The entire alkane chains are dependent on the oxygen only. The oxygen is the functional group. Here the oxygen is the functional group. Generally the compounds are called ether compounds. If you have two side chains with the oxygen, the compounds are called ether compounds. In this ether compounds, you have to get the root word. Here you see the carbon is attached with oxygen. This carbon is attached with oxygen. So if you have this one, this group if you have this group substituent, that means on the alkane you have the substituent. So again it automatically, it is a derivative of alkane only. So it is alkane, the alkane linked with oxygen. So this group is called alkoxy group. What it is called? Alkoxy. Alkoxy on alkane. So the root word is called alkoxy alkane. What is the root word? Alkoxy alkane. One becomes alkoxy and another one becomes alkane. If it is methyl, so methoxy. If it is methane, so methoxy methane. Ethoxy ethane. Propoxy propane. Methoxy ethane. Ethoxy butane. Like that you are nomenclating. There, the ether when you want to nomenclate, the root word is alkoxy alkane. Common name is ethers. The oxygen, if it is bonded to with carbon chains, so the oxygen is the functional group. That functional group is called ether functional group. And one more. So oxygen is bonding to the two bonds I am bonding with carbon only. The two bonds are bonded with carbon only. So again it is the carbon, still it is having two bonds. So what happened here? The oxygen is bonding with carbon. The carbon is bonded with oxygen. What group you form? CO group is formed. The CO group compounds are called carbonyl compounds. What they are called? Carbonyl compounds. So in the carbonyl compounds, when you observe it is C double bond O, still the carbon is having two bonds. So what I am doing? One side I am adding the hydrogen and the other side I am adding the carbon. So what happened? One side if I added hydrogen, that you are not able to extend. That is didn't. So one side the carbon is added, the carbon is having the chain. So here you happen. So the lastly what you are getting, one group you are forming, that group is CHO. What is the group? It is CHO. This group is called aldehyde compounds. What they are called? Aldehyde compounds. They are the carbonyl compounds only. The one side hydrogen, if you have one side carbon, the one side because of the hydrogen you are getting one group, dead end group, the CHO group. The CHO group compounds are called aldehyde compounds. And one more, the functional group, the CHO functional group is having the carbon. They are called carbon contained functional groups. What they are called? Carbon contained functional groups. So we have to mention this carbon also in the alk. Why? Because that carbon is having the functional group. The functional group itself, it indicates the carbon also. So the carbon contained functional group it is CHO. The C also counted. So it is called carbon contained functional group. The compounds are called aldehydes. So what is the root word you see? The aldehyde is the derivative of alkene only. Why? Because this side I am increasing the chain. So what you are getting the R, the one side the CHO. R CHO you form. So the CHO is the aldehyde. It is in the alkane. So they are the derivatives of alkanes. So how I am getting the root word? You see, in the alkane I am eliminating the E, and in the aldehyde I am adding the Al. So what the root word you are getting? Alkanal. What is the root word? It is alkanal. And one more you see, C double bond O, this side the carbon and this side also I am adding the carbon. This side you can increase the chain, this side also you can increase the chain. It is the R and this is also the R. To get differentiate, one is R1, the second is R2. It is linked with CO group. What the group is linked? The CO group is linked to two carbon chains. So they are the derivatives of alkanes only. This CO group is called ketones. What they are compounds? They are called ketones. So in the ketone, they are the derivatives of alkanes only. So I am getting the root word. How I am getting the So carbon and hydrogen, here you have two oxygens. Two oxygens are the heteroatoms. So what is the functional group we are going to form? You see, the one oxygen with a double bond and one oxygen attached to the carbon. So here oxygen has to form one more bond. If the one more bond with the hydrogen, what happened here? That you are not going to extend that one. So you are having one dead end. The COOH group is formed. The COOH group is formed, so the compounds are called carboxylic acids. What they are called? Carboxylic acids. So here COOH group and dead end group you are formed. The compounds are called carboxylic acids. Here the carbon here increased. This is called resin. So COOH compound you are formed. So the compounds are carboxylic acids. So here you see, this is the derivative of alkane again. The alkanes, so how we are writing it is alkane. In the alkane the E is eliminated and it is oic acid is added. So what you added? Oic acid. So the root word you are forming alkanoic acid. What it is? Alkanoic acid. So here you see C double bond O and O. So here instead of hydrogen I am adding carbon. This side also carbon. So what happened? This side the carbon chain is increased. This side also carbon chain is increased. Two R resins are formed. So to get differentiate, one is R1, the other one is R2. So what you are forming? COO. R, COO, R you are forming. These compounds are called ester compounds. What they are called? Ester compounds. Here you see RCOO group. RCOO is good. Alkanoid. What it is called? Alkanoid. Alkyl alkanoid. What it is? Alkyl alkanoid. So what is the root word? It is alkyl alkanoid. And one more compound, the carbon and hydrogen. Here the heteroatom is the nitrogen. When the nitrogen is the heteroatom, here is nitrogen. So generally with three hydrogens, what you form? The ammonia you form. So here in the ammonia, one hydrogen I am replacing with the carbon. So what happened? The chain is increased. So what you form? The R you form. The remaining it is NH2. So the ammonia, in the ammonia the hydrogen is replaced with the carbon. So the compound is the derivative of ammonia. So that's why they are called amine compounds. What they are called? Amine compounds. Same similarly the second possibility, this hydrogen also replaced with the carbon. So this side also carbon chain is increased. The two R's are formed. The R taken twice, it is NH. So here also it is the derivative of ammonia only. So the compounds are called amine compounds. Same similarly third hydrogen also replaced with the carbon. So here also the possibility, the hydrogen is replaced with the carbon. So the three carbons are replaced with the hydrogens. So R3N you are formed. It is also the derivative of ammonia only. So they are also called amine compounds. But what is the difference here? You see, in the first compound, the one nitrogen is attached with the carbon. In the second compound, the nitrogen is attached with the two carbons. In the third compound, the nitrogen attached with the three carbons. If the nitrogen is attached with only one carbon, they are called primary amines. So if the nitrogen is attached with the two carbons, the compounds are called secondary amines. If the nitrogen is attached with the three carbons, the compounds are called tertiary amines. The three are the ammonia derivatives only. They are called amines. If the nitrogen is attached with only one carbon, what you are forming? One amine, the primary amine you are forming. If the two carbons are attached, secondary amine you are forming. If the three carbons are attached, tertiary amine you are forming. If the carbon it is attached with the nitrogen, the three bonds with one carbon only you form. These compounds are called nitrile compounds. What they are called? Nitrile compounds. Or they are called cyanide compounds also. The carbon with nitrogen, the triple bond form. The three bonds with one carbon only it is formed. This type of compounds they are called nitrile compounds. And that the carbon and hydrogen, so with nitrogen and oxygen you are forming. The nitrogen and oxygen are the heteroatoms. They are in the group of NO2. This group is called nitro group. So the compounds are called nitro compounds. So like that, the heteroorganic compounds we are classified and we find the root word. There, if the halogen is the heteroatom, the compounds are called alkyl halides. The root word is haloalkane. If the oxygen is the heteroatom, if it is in the OH form, the compounds are alcohols. The root word is alkanol. If the oxygen is the heteroatom and it is bonding with two carbons, the ethers or compounds are ethers. That is alkoxy, alkane, the root word. If the carbon is attached with the one oxygen, the double bond if it is formed, CO group is formed, the compounds are carbonyls. In that one is aldehydes and the second one is ketones. With the carbon and hydrogen, two oxygens if you have, it is one oxygen is attached with double bond, one oxygen with single bond, and the remaining bond with hydrogen, the COH group is formed. The compounds are carboxylic acid, alkanoic acid, and the COO group it is formed. They are called esters, alkanoid, alkyl, alkanoid. Similarly, ammonia derivatives we are forming the amines, primary amines, secondary amines, and tertiary amines. And the nitrile groups we are forming. Similarly, nitrogen and oxygen is the heteroatoms. So you are forming nitro compounds. They are the root words. Based on the root words, here you see in the root word the alk equal to that is a number of carbons. If you substitute the carbon numbers, so automatically you are getting the compound names. And again the IUPAC rules are same. If you have the substituents if they are same, di, tri, tetra, penta, like that prefixes you have to add. If they are different alphabetical orderly, the compound should be nomenclated with the root word and the alk and that compound positions if you have mentioned, so automatically the nomenclature is completed. It is one topic of your organic chemistry. So in the GOC, General Organic Chemistry, we have discussed up to the nomenclature. So here some more topics we have the isomerism and the reaction mechanism, how the bonds are cleavated, what are the radicals that you are formed, that free radicals, electrophiles, nucleophiles, and how they are reacted. What are the reactions? We have the substitution reactions, that nucleophilic substitution reactions, electrophilic substitution reactions, and free radical substitution reactions. At the same time, addition reactions, elimination reactions, rearrangement reactions. Like that we have the reaction mechanism also, that we will see in the part 2. And one more thing, please don't forget to subscribe. Please like, share and comment and subscribe. Keep on watching the video. Thank you.